inverse of a relation. It will start from here. So can anyone define how will you define relation, inverse of a relation? So suppose we call R is from A to let's say B. So how do you define R inverse of a relation? So anyone can respond. If you don't respond, anyone will not respond, then I will tell your name. So how do you define inverse of a relation?
Sir, if a relation such that in X belongs to A and Y belongs to B, then the inverse is Y belongs to B and X belongs to A.
Okay, you tried good, but like, how do you define? So if R is a relation from A to B, then R inverse will be from B to A. And how do you define? So like, we write R as suppose, or R inverse if directly I define. So it is like, instead of AB, you will write here BA, such that AB belongs to R. So this is definition of R inverse. Okay, so R inverse is set of order pairs BA such that AB belongs to R. If A and B are related, then in R inverse B will be related to A. So in relation R, if A is related to B, then in R inverse B will be related to A. So inverse. For example, okay, uh, so this is inverse. Okay, so we call it R inverse of a relation. So what I'm defining, inverse of a relation. So for example, let's say A is a set 1 2 3. Okay, assume B is a set 5 4 7. Assume, okay, and R we are defining, suppose the relation is like 1 7 2 5. Okay, 3 4. Okay, this is. So can anyone tell what is R inverse here? So R is given to you. So now you are you know, you are asked to tell R inverse. So what is R inverse? So anyone tell me what is R inverse? R is given to you, then what is R inverse? How do you define inverse of a relation? So example I have given you. Now you have to tell me the answer for the R inverse. You may look definition. So this is the definition. This is the definition.
7152143. Sir, 715243.
715243. Right. So this is correct answer. So just when A is related to B in R, so in R inverse B will be related to A. You just have to change the order. So fine. So this is your R inverse. Like in second example, this is example one. If I write example two, so example two, suppose in the same relation I write like A as, so A is any set. So if I take the example from the book, so they are telling you that we are defining set Z, you know, set of integers, set of integers, and set of integers are actually like 0 plus minus 1 plus minus 2 and so on. Okay, these are set of integers. So we are defining a relation from Z to Z. Okay, and R is like AB such that AB such that, and here we will have, suppose A is less than B. So what is R inverse? Now tell. So what is R inverse? So relation R is AB, and in exams like there will be four options. Then which of the following is R inverse? Like that question may be asked. So what will be the answer? बताओ। ट्राई करो, कोई भी ट्राई करो. You try to answer. So R is a relation, order pair AB means A is related to B if A is less than B. So what will be R inverse? So how will you write R inverse?
Sir, B comma A, B is less than A.
B comma A such that B is less than, no. So that will be same thing. Actually, what is the definition of R inverse? So definition is this. I'm writing definition first. So definition is R inverse is B comma A such that AB belongs to R. So B comma A such that AB belongs to R. This is definition of R inverse. So just you keep B comma A as it is and now you tell. So AB belongs to R if A is less than B. So this line is equivalent to A is less than B. So R inverse is this. So R inverse is this one. So this is the answer. If you want to correct it, so now you can correct it. Now you can correct it means you don't want to write BA, you want to write AB. So no problem. You interchange B to A to B. So here you also interchange. So B less than A. This way you can write. Both are same thing. So there you are also doing the same, but that is not R inverse. That was R only. So R inverse is this one. AB such that B less than A. Here R was, now you can see both are inverse of each other. See here. Compare these two. So here we had A related to B if A is less than B. That was R. Here A related to B in R inverse. So B less than R. Just is inverse of that. Okay. So that is called inverse. So you just remember the definition. So this was theoretically, this was like we call this form as roster form and this we call set builder form. So this form is called set builder form and that form is roster form. Okay, so this is inverse. There is one more word. So do you know the word? Complementary relation. So what is complementary relation? Complementary relation. So like I was discussing inverse earlier, now it is complementary relation. So what is complementary relation? Anyone please define? So suppose we call R is a relation, like R is. So how do you define? Complement. So you know set complement. है ना? So R is relation from A to B. So R complement. What will be? R complement. Complementary relation. So R complement will also be from A to B, but how will you define? So how will you define R complement? Like you define R inverse. So in that way, how will you define R complement? Complementary relation, how will you define? Yeah, anyone please try. Try quickly. You can look into notebook, book, anything. But you tell because you have done this. It is not, the first time you are looking this word. This word you have already seen, like when sir was teaching this. So suppose in exam they will ask you, so what will you say? What will you answer?
A cross B minus R.
A cross B. No, actually, R inverse was what? R inverse was no, BA such that AB belongs to R. So it's a complement. So complement में क्या होता है जो R में नहीं है, like it will be A comma B such that AB does not belong to R. तुम्हें पता है ना कि रिलेशन इज अ सबसेट ऑफ A क्रॉस B. तुम्हें वो सारे एलिमेंट कलेक्ट करने हैं जो कि R में नहीं है, तो वो हो जाएंगे R कॉम्प्लीमेंट. फॉर एग्जाम्पल जैसे चलो ए मैं एक सेट लेता हूँ, मान लो 1 2 सिंपली, और बी एक सेट है 3 4। तो ए क्रॉस बी, मुझे कोई बताओ ए क्रॉस बी, ये भी तुम लोगों को आता है या नहीं आता है? ए क्रॉस बी फाइंड करना आता है क्या, कार्टेशियन प्रोडक्ट ऑफ टू सेट्स? तो बताओ जल्दी से कोई, व्हाट इज ए क्रॉस बी? इन दोनों सेट को मल्टीप्लाई करना है भाई। ये भी नहीं आता क्या तुम लोग? 12th पास किए हो या ऐसे ही आ गए बीटेक में बिना 12th पास किए? ये सब 11th क्लास में है, मतलब 11th क्लास का पहला चैप्टर है सेट थ्योरी, उससे आगे दूसरा चैप्टर आता है रिलेशन फंक्शन, तो उसी बेस्ड है, वी आर मल्टीप्लाइंग टू।
1 3
यस, 1 3
1 4
1 4
2 3
2 3।
and 2 4.
Yes, so why are you taking so much time? Don't you tell quickly? Okay, so this is A cross B now. And now suppose I will give you R as, let's say 1 4, and suppose 2 4. Assume this is the relation R. If I ask you what is R complement, what is R complement? So look at the definition of the complement. So this is the definition of complement. So this is complement of a relation. Definition of complementary relation. Complementary relation. So now you tell me, this is one relation given to you R, and now based on this R, what is R complement? You tell.
1 3 and 2 3.
So like you will check which elements are not in R. So from A cross B, you select only those elements that are not here. So 1 4 is there, you won't take. 2 4 is there, you won't take. So you will consider 1 3 and 2 3, right? So this is correct answer. So complement means you will leave those elements which are already in R. है ना? So AB does not belong to R, you take those elements. So like 1 4 belongs to R, 2 4 belongs to R, so you will leave that. So those who do not belong to R, you will take in R complement. Okay. And like if here in the same relation, if I ask you what is R inverse, this is complement. What is R inverse here in this example? What is R inverse in this example? According in this example, what will be R inverse?
4 1 4 2.
4 1 and 4 2. Yeah, correct. 4 1 and 4 2. Okay. So this you know already. Try to respond early, because no, many of you already know this thing, because this has been taught to you already. It is not the first time you are doing. Now, so you have seen inverse complement. Okay, if I come in this part, so in this example, like R was a set of order pair AB such that A is less than B. In this case, now you tell me what is R complement. So since we have written this relation in roster form, set builder form, not roster form, set builder form. So we have to write the answer into set builder form only. So tell me, what should I write? Hmm. Tell. So what is the definition of R complement? AB such that AB does not belong to R. So those elements, yeah, those ordered pairs of A cross B that are not in relation R. So that will come in R complement. So here,
Sir, if AB A greater than B.
1 minute. So AB does not belong to R. So means if AB belongs to R, it is A less than B. Does not belong to. So less than का opposite होता है greater than equal to. The A greater than equal to B. Okay. So it is not belong to na. So like it was A less than B in R. So you cut it. Not belongs to. So this is equivalent to writing A more than equal to B. You cannot ignore equality. So if it is not less than, means they are more or equal. So this is the R complement. Okay, so this is your R complement corresponding to this relation. Okay, so we discussed two examples of inverse and complement. So complementary relation and inverse of a relation. Now I will ask you, so you have done composition, right? Composition of relations. Okay, so let's see composition of relation. Composition of relation. Okay, so composition of relation. So what will happen? Like if R is a relation on set A, so let me tell you, A is suppose 1, 2, 3. Okay, and R if I give you, it is like 1, 1. Okay, 2, 1, 2, 3, and 4, 3. Okay, so 1, 1, 2, 1, 2, 3. Sorry, 3, 2, and 4, 3. Right. So 3, 2, and 4, 3. Now I'm asking you to find R square. So R square means R composition R. O is a composition. So R composition R. So you find R square. Tell me. So you please try and tell. So again, you have seen this thing. If something is new to you, you can tell because relation part is already finished, completed by Saurabh sir, no? So I'm just doing revision. Tell me quickly. You know the composition like A. So here I'm writing relation from A to A only. Oh, 1 minute. So something is wrong here. So something is wrong. So I have to give 4 also. 3, 4 because I've used 4 here, na? So I have to give you 4. Yeah. So set A has 1, 2, 3, 4. A has 1, 2, 3, 4, and A has 1, 2, 3, 4. All are A. So A to A we have relation R, A to A we have relation R. I want to find the composition. So this will be composition R square, or you call it ROR, from this set to this set. Now I have given you a hint. So from first to third A will be R square. R square means, so R square means ROR. Hmm. हुआ भाई किसी का नहीं हुआ क्या? ये टॉपिक पढ़े हो कि नहीं कभी पहले? कंपोजिशन ऑफ रिलेशन पढ़ा है कि नहीं? हाँ ना जवाब दो.
याद नहीं है सर।
ओके, याद नहीं है. अच्छा, किसी को याद है? तो सब भूल गए. एग्जाम में भी यही करोगे, याद नहीं है. देखो क्या है कि यहाँ देखो रिलेशन आर में क्या हो रहा है. वन का मैप किसके साथ है? वन के साथ है. चलो वन का मैप है वन के साथ, और टू का मैप है वन के साथ, टू का मैप है वन के साथ, थ्री का टू के साथ, और 4 का 3 के साथ। ओके, अब वही वाला रिलेशन फिर से देखो, क्योंकि बिकॉज दिस इज अगेन आर। सो 1 1 के साथ, 2 1 के साथ, 3 2 के साथ एंड 4 3 के साथ। ओके, अब तुम सीधा फर्स्ट सेट से लास्ट सेट में देखो। अब तुम वो रिलेशन लिखो, पहले सेट में देखो 1 का रिलेशन तीसरे सेट में किसके साथ है? बताओ, ध्यान से देखो। पहले सेट में 1 का रिलेशन तीसरे सेट में किसके साथ है? दिख रहा है, नहीं दिख रहा है तुम लोगों
वन
को?
वन
दिख रहा है ना, 1 1, तो 1 का 1 के साथ है। पहले सेट में जो 2 है वो देखो तीसरे सेट में किसके साथ है? सेट मतलब ये बोल रहा हूँ, ठीक है ना, ये सेट है एक। सो तीसरे सेट में किसके साथ रिलेशन है?
3.
नहीं,
टू
पहले
वन
सेट में जो 2 है वो दूसरे सेट में किससे रिलेशन है उसका? सॉरी, तीसरे सेट में। ध्यान से देखो,
वन के
2 गया 1 पे और 1 का मैप है 1। कहाँ हुआ मैप? ये जो 2 है फर्स्ट सेट में, वो तीसरे सेट में कहाँ मैप हो रहा है? अभी भी समझ नहीं आया? 2 का रिलेशन किसके साथ है? 2 का रिलेशन पहला सेट में, ये पहला सेट है, ये दूसरा सेट है, ये तीसरा सेट है, मैं ये बोल रहा हूँ। तो फर्स्ट सेट में जो 2 है वो तीसरे सेट में किसके साथ रिलेशन है?
Once.
1 के साथ, हाँ। तो इतना टाइम क्यों लग रहा है? 3 इन द फर्स्ट सेट इज मैप्ड टू व्हाट इन थर्ड सेट?
So one.
Again it is 1, yes. And 4 in the first set is mapped to which element in the third set?
Two.
4 का 3 और 3 का 2 के साथ, तो 2 हो गया। सो दिस इज अ कॉम्पोजिशन आर स्क्वायर। So this is ROR. So composition. So we are mapping, है ना? We are taking composition over two relations, and they are same here. So R is A to A, then again R is A to A. Then we have to look first to third set. That is the composition. So this is R square. Similarly, can you try R cube? So now try R cube. What is R cube? You try to find R cube like I find R square. You similar way you try to find R cube.
So one one and four one.
Only. No, it will have also have four elements like this. So R cube you can write like R square composition R, or you may write R composition R square. Any one way you can write, or you can think of R composition R, like this. Tell me what will happen.
सर 1 1 2 1 3 1 4 1
Okay, 1 1 2 1 3 1 4. Okay. Yeah, others please try.
Yes, so 1, 2, 1, 3, 1, and 4,
Now you
1.
can map one more time here. So you may take one more composition here R, okay, and one, two, three, four. So you know there's one map to one in this relation, okay, like it was given. Two map to one, three map to two, four map to three. Now you just look from first to last because R cube you want to find now. So three compositions are there R, R, R. So first one, one, one. So one goes to one. Okay, now you look two goes to one goes to one goes to one, so it's a 2 1. Yes, you have to look into first and last, okay, first and fourth set. So two goes to one goes to one goes to one, three goes to two goes to one, so 3 1 also. Then four goes to three goes to two goes to one, so four goes to one. So this is uh, R cube. Similarly, if you find more, like more set you can take, so you can increase one more composition like that. So that will give you R4. So R4 will be same as R3. If you find, they can it will be same as this, will not change. R5, R6, all will be same as this. You can try to find. So this was composition. So we started with inverse, complementary, composition. Now let's find. So I will write one more example. So the A set I have 1 2 3, okay, and B set I have 1 2 3 4, and R1 relation is 1 1 2 2 3 3, okay. So R2 we have 1 1 1 2 1 3 1 4, okay. So simple operations, like if I ask you what is R1 union R2. So this is very easy to tell, right? So anyone tell what is R1 union R2? Union of two relations.
Sir, all the elements of R1 and R2.
All
Yes.
the elements.
What are those? You can tell name. So what should I write?
One
Answer.
one, 1 2, 1 3, 1 4, and 2 2 3 3.
1 1 1 2 1 3 1 4 2 2 3 3. Right? This is union. Yeah. So union of two relations. Similarly, if I ask you R1 intersection R2, then what is R1 intersection R2?
1 1.
Hmm.
1, 1.
Okay, 1 minute. Can you repeat, please? What is R1 intersection R2?
1, 1.
Yeah, so common element you will search, right? So it is 1 1 only. Then what is R1 minus R2? So difference of two
3
sets.
3.
Hmm?
2 3 3.
2 2 3 3. So R1 minus R2 means those elements of, so those elements of R1 which are not in R2. So R1 minus R2 means those elements of R1 which are not in R2. So you see in R1 those elements in R1 which are not in R2. So that are 2, 2 and 3, 3. Yes. And tell me R2 minus R1.
1, 2,
Mhm.
2, 3, and 1, 4.
So those elements of R2 which are not in R1. Oh, 1 minute, 1 minute. So here I did miss. Sorry, sorry. We are looking in R2, na? Yeah. So R minus R2. Uh, so 1, 2, 1, 3, 1, 4. Yeah, you're right. So 1, 2, 1, 3, 1, 4. Those elements of R2 which are not in R1. Okay. Those R2 minus R1 means those elements of R2 which are not in R1. So those are this. So, okay. So these are. Next we have. Today we are running out of time. Is it? So okay, so I think that's all. In last class we discussed. I think did we discuss reflexive, symmetric, transitive examples in last class?
Yes, sir.
Okay, so that's all. Like mainly these are the topics only in relation. So in relation they have what is relation, then reflexive, symmetric, transitive, equivalence. Okay, then like I discussed inverse, composition. Okay, and then like we discussed complementary. All this. There is one relation. Anti-symmetric. You have, do you know this name? Anti-symmetric or asymmetric. So what is defined here? Here it defines symmetric, anti-symmetric. Yeah, fine. Anti-symmetric relation because there is asymmetric also. So here in the syllabus you have this also anti-symmetric relation. है ना? Other than reflexive, symmetric, transitive, you have this anti-symmetric. So can anyone define what is anti-symmetric relation? Anyone? Do you know? So suppose R is a relation on set A. So when can we say this R is antisymmetric? So the definition is if AB belongs to R and this is assumption BA belongs to R, then A will be equal to B. So A belongs to R, BA belongs to R, then A is equal to B. For example, one relation I can tell you R is suppose R to R, okay, real number to real number, and this, you know the difference between this and this. So simple R is relation, okay, and this R is actually real numbers. Okay, so difference you can notice. This is common R. Uh, this is common, and this is something extraordinary. Extraordinary means something different. One extra line I've done. So in the book you will see it is a bold R. Bold R means set of real number. So in the book you will also see the difference. One will be simple R, other will be bold. Bold means there are set of real number. So okay, so what I'm telling, relation is like A comma B such that A is less than equal to B. Okay, so if we want to check whether it is antisymmetric, so you will assume AB belongs to R and BA belongs to R. Okay, so AB belongs to R means A is less than equal to B, and BA belongs to R means B is less than equal to A. If A is less or equal to B and B is less or equal to A, so what do you conclude? So what can you conclude from these lines? A less than equal to B and B less than equal to A.
A
So what is
equals to.
right? A is equal to B. There is only choice this. So therefore this relation is anti-symmetric. So okay, so like we covered almost all the topics in relations, okay, with examples. So this was revision class. So like in the revision also we covered almost all. Okay, I think that's all for today. Thank you.
Thank you.